Right. We are back. Let us finish this. I hope you guys downloaded the handout. So we'll come to it in a few minutes. Let us, what is my table? Okay, this is it right here. Okay, this is where we are. So binomial distribution, that's where we are. So these are the notations we use for the binomial distribution. P is for the probability of success. Q is for the probability of failure. And Q is always 1 minus P. N is the number of trials. X is the number of success in N trials. Remember that the binomial distribution is a binomial experiment, and they correspond the outcomes of a binomial experiment and their corresponding probabilities is what gives us a binomial distribution. So to calculate binomial probabilities, we use what we call the binomial formula, which goes like this. Okay, you can see right here. Probability of X equals to N combination X. We did this combination yesterday. Times P to the power X times Q to the power N minus X. And the X values start from 0 all the way to the last N. So we are going to be using this formula to calculate binomial probabilities. All you need to do is to find the values for X, N, P, and Q. Let's try this example. It says, find the probability that in 5 tosses of the first dice, I call it dice. The first dice, 3 appears at no time, once, twice, 3 times, 4 times. So let's start from here. Excuse me. Solutions. You guys can see the screen, right? Can you?
Yes.
Yeah. So it said that in 5 tosses, so N is 5. Say 5 tosses, and that's N stay the same, doesn't change. And for a dice P, if you remember a dice, it has 6 sides. I think I normally have one to use in the class. When I'm teaching the class, I have one. You can see the dice right here. It has 6 sides. Okay. Now, the dice, so P will be 1 out of 6, which gives us 1 over 6. Okay, 1 divided by 6. Give us 0.16667. That means 0.167. 0.167. Okay. 0.167. And Q is always 1 minus P, which is 1 minus 0.167. Okay. So that's what's gonna P gonna, excuse me. So 1 minus that. One minus 0.167, 0.833, 0.833. So once you got this 3, you are ready to answer the questions. So we'll be using these 3 terms, N, P, and Q, for each of these to answer each of these questions. So the first one says at no time. A says at no time. That means our X equals 0, because say at no time. So that probability of at no time, remember the formula is here. So where X is 0. So that probability of at no time is 0. okay, becomes n combination x. N is 5. Okay, n is 5. N combination x. That means 5 combination x is 0 times let me put this. Okay, 5 combination 0, make it big. Yeah, times p to the power x. P is 0.167, 0.167 raised to the power x, and our x is 0 times, okay, I'm gonna put this, and times q to the power n minus s. Our q is 0.833, 0.833 raised to the power n minus s. Our n is 5. 5 minus x. Our x is 0. So that we have our answers. Okay. Okay. We're waiting. So that we have this. Once you have this, we can now go to the calculator and put this in. I'll put this in our calculator and we get our answer right away. Okay. Now let's do it. In calculator, the first part is 5 combination 0. So we're gonna get it. That's why I say learn this. When I was teaching it yesterday, I say it's good that you know how to do it with a calculator. That will help you. That will be better for you. 5 combination NCR. Okay, let me do this. NCR have 5, 0 times now times, okay, for P 0.167, okay, raised to the power, you can see it?
Yes, we can see it.
Okay, raised to the power 0, okay, times 0.833. Raised to the power 5 minus 0 is 5. Anyway, so just 5. 5 minus 0, like. So excuse me. 5 minus 0 is 5. So you can see by the time you start doing it manually to get this part, it will take you a long time. So just learn how to do it with the calculator to save your time. So the answer is 0.40107. I mean 0.401. So we go to our work and put 0.401. 0.401. Questions for this? Any question? Good. Yeah, answer part A. Part B says A3 appears once. In that case, X is 1. So plug it in. So the probability of 1, okay, for 1, use the same formula. So I'm gonna just copy it, just change these zeros to 1. Probability of 1 will now, because so change this to 1 this time. 1, and then change this to 1. Okay, raised to the power 1. 1 is this about 5 minus 1. Okay, so that we can find the answer now. Put this in the calculator. So 5 combination 1. Okay, I'm gonna repeat this. 5. Okay, 5, 1. Okay, times 0.167 to the power 1. Excuse me. 0.167 raised to the power 1. Okay, times 0.833. Okay, 0.833 raised to the power 5 minus 1 is 4. So raised to the power 4. 0.402. See, 0.402. Okay. So you put it 0.402. 0.402. So you keep going like that because M stay the same, P stay the same, Q stay the same, because if we remember when we were doing the properties, so that there must fixed number of trials, so N stay the same. See? So now part C says twice. So twice, as part C says twice. A 3 appeared twice. That means our X equals 2. So plug it in. P2. So P1, P2. So I'm going to just pick this up. Okay. Change this to 2 twice this time. 5 combination 2. Okay. Combination 2 has 0.167 raised to the power 2. And 0.83 raised to the power 5 minus 2. So I'm going to take this thing off. Okay. So then we're going to a calculator, 5,2. Okay, 5,2. Okay, times 0.167 raised to the power 2. Okay, times 0.83 raised to the power 5 minus 2 is 3. So raised to the power 3. 0.1612, I mean 0.161. 0.161. Okay, 0.161. Yeah. Questions so far?
Yeah, Professor, I have a question.
Mhm.
Yeah, can you go up to a little bit, please? The P, which is equals to 1/6, is that constant, or that the die is going to be 1 over?
Yes, because it says here, the probability of success must remain the same for each trial.
Okay, all right.
That's why I said I mentioned it. I said that all this will be constant. The only thing that will change is the X.
Okay.
So but this say 3 times. Put it at D 3 times. In this case, S is 3. So the probability of 3. Just do the same thing, change this to 3. Okay. P3, plug it 3 into the formula, and the other values stays here. 3, 5 combination 3, 0.167 to the power 3, 0.832 to the power 5 minus 3. And then we go to our calculator and get our results. Yeah, 5,3. I'll have 5 combination 3, 5, 3. Okay. Times 0.167 raised to the power 3. And times 0.833 raised to the power 5 minus 3 is 2. Am I right? Give me 0.032. 0.032. I hope you guys printed that table I said to download and print. Hope you did. Hello,
yes.
class?
Yes.
Good. Now, the last one in that section is E, 4 times. See, 4 times, in that case, S is 4. So this is how to do binomial. This is basically how to do binomial probability using the formula. X is 4 this time. Okay. So at P4, you just change this to 4. Okay. Now it's gonna be 4 here. Change to 4. 5 combination 4. 0.167 raised to the power of 4. 0.833 raised to the power of 5 minus 4. So let's go and get our results. So that we have 5 combination 4. Okay. All right. 5 combination 4. Okay. All right. Times 0.167 raised to the power 4. Okay, times we got our 0.833 raised to the power 5 minus 4 is 1. Raised to the power 1. 0.0032. So 0.003. It's good enough. 0.003. So we have answered all the questions. Probably that it will 3 appear at no time, once, twice, 3 times, 4 times. We answered all of them here. Question before we answer a new example. Good, excellent. Now, let's look at this example here. It is it is claimed that a particular flu shot is effective in 70% of cases. If there are 15 adults who receive, if a group of 15 adults receive the flu shot, find the probability that exactly 10 will benefit from the shot. Exactly 10. Solution. Yeah. Here, how many people are given this shot? How many? How many people receive the shot?
15. 15 adults.
N is 15 then. N is 15.
Professor.
And it says that it is clear that in a particular flu shot, 70% of cases, that a particular flu shot is effective in 70%. So P is 70. P is 70%, which is 0.770. And Q is always 1 minus P. Always 1 minus P, which is 1 minus 0.70, which is 0.30. You can verify this with a calculator. Now, the question they ask us here is that if 15 adults receive the flu shot, find the probability that exactly 10 will benefit from the shot. So our X is 10. That's good. So now, to find the probability that exactly 10 receive it, we use the formula for the binomial. Here, the formula goes like this. Okay, now in this case, we plug in anywhere we see X, we put 10. Anywhere we see N, we put 15. Anywhere you see P, you put 0.7. Anywhere you see Q, you put 0.3. So that P10, probability of that 10 of them, exactly 10, will become 15 combination 10. Okay. 15 combination 10 times P, which is 0.7, 0 raised to the power 10 times, okay, raised to the power 10. Yeah, and I gotta fill this. And this one, I'll make it bigger, make it up to 16 possible. Make it 18. Yeah. Times 0.3 for P. for this q here, 0.3 raised to the power n minus x, which is 15 minus 10. Okay, 15 minus 10 equals. Okay, now we can go to our calculator and plug this in and get our answer right away. So we have
Hello, Professor.
Yeah.
I wanted to see the question.
Okay. Take a photo of it. Say it. It is claimed that. Can you see it now?
Yeah.
Take a photo of it. Have you taken the photo?
No.
So what's Q1?
Huh?
Where is Q1 coming from? I mean, Q is equals to 1. Okay.
All right, thank you.
I get it.
Okay, good. So you have I gotta write this thing down somewhere. Why did I write it down? Anyway, we still remember it though. We have let's go to the calculator and get this out of the way. So have 15 combinations, 10, 15, 10. Okay. All right, times. We have 0.7 raised to the power 10. Okay, times 0.3. Okay, raised to the power 10 minus 15 minus 10 is 5. 5. And I got 0.206. 0.2061. 0.2061.
Where is
Okay.
5 coming from?
What?
I get it.
0.2061. See? 0.2061. Now, that's the answer. Now, I want to show you. Remember, I told you to print that table. So I'm going to show you how you can answer this type of question from the table. So this is my table right here. So you can see the binomial. You can see binomial probability. Now, that table I say print have many tables. This is just one of them. This is just table 4. Tomorrow we start using table 5. So table 4 go all the way to 15. And remember that the question was, if you look at table 4, they use for x, they use R for x. You can see all the P's. You can see the P right here. You can see the N right here. So now, that question asked us to, it says, in 70% of the cases, so I think I'm going to move this to this side. So sorry, it's claimed that a particular flu shot is effective in 70% of all the cases. So that's our P is 70%, that's 0.7. A group of 15 adults, so our N is 15. Find the probability that exactly 10. So if you're using the table, you don't need the Q. All you need is MPX or MPR, they call it R in the table. So you see 70% is 0.7. And you can see, you know what, I'm going to move it to this side. 0.7, and you can see an N for 15. You can see the N right here. You can see the 0.7 for P, CCP, 0.7. And out of 10 of them, right? So from this 0.7, you go under 15. Then from 15, you can see the R. You look for, so from 0.7 to 15, okay, then to X, which is the R, or 10. So 0.7 all the way down, we are now in 15. Then here you look for 10. This is 10 right here. You follow it to 0.7. Okay, you can see it right here. 0.206. 7,
papers are filled
206, you have 206
crime directly
under
of
10,
skyrocketing.
15.
And local
You can see the
authorities
answer, see the same answer we have. You can see it right there.
is so overwhelming for law enforcement is the sheer.
Please mute yourself, please.
They are available in every
Please,
farm.
can you mute yourself? Now, you can see the answer.
Sorry.
You can see the same answer we have here, 0.206, which is right here. 0.206 is right here. You can see 0.206. If we round it to 2 decimal, you can see that it is the same thing. So you can get it with table faster. All you have to do is to put the numbers in, or you can just put P10, then put your answer there and mention that you use the table. That's it. Yeah.
I have a question.
Yes, ma'am.
Is the table uploaded on Canvas?
Yes. Before we left, before we had time that I showed you where it is on the file, and I said print it out.
Okay, thank you.
You're welcome. Yeah, before we had time that.
Can you show us how to use the table again? I think
Yes. This N is 15. Whatever you use, you only need the N, P, and Q. Sorry, N, P, and X. So our N is 15, our P is 0.7, our S is 10. The table use substituted R for X.
okay.
So you go there. This is your P right here. I see the P is 0.7. And this is the N, 15. And this is your X for 10. This is 10. See? You go from 0.7 all the way down to 15, which is here. From 15, you go to 10. So look at the 10 right here. Then you go under 0.7 right here.
Okay.
You can see right there. That gives you the answer right away. So that's what I wanted to show you. Any other question before we try the last example in this section? I think you're good. Should be good now. Okay. So look at this one. It says, a survey found that 30% of teenage consumers receive their spending money from part-time jobs. If 5 teenagers are selected at random, find the probability that at least 3 of them will have part-time jobs. Now, in this, it says at least. That means you're gonna find use the formula 3 times or 4 times, depending. We'll find out now. Solution. First of all, our N is, say, if 5 teenagers were selected, so N is 5. Yeah. And let's find out P. It says it's really found that 30% of teenagers receive their spending money from part-time jobs. So P is 30%, which is 0.3. Now Q, we don't need Q. I want us to use table for this one because it says at least 3 of them. That means you're gonna find 3, 4, 5 and add them. So you gotta do the formula 3 times. That will take you a lot of time. So the best is to use the table. So now question says, if 5 teenagers are selected, find the probability of using at least that at least 3 of them will have part-time jobs. So that means our X will be at least 3. That means 3. At least 3 means 3 or more. So from 3, 4, and 5. Why do we stop at 5? Because our N is 5. So as the probability of at least, please mute yourself. 3. We have 10 minutes left. At least 3 means probability of 3, yeah, plus probability of 4 plus probability of 5. So if you're using the formula, that means you're going to calculate the probability of 3. then calculate the probability of 4 using the formula, then calculate the probability of 5, then add them. That will take you time. So but with table, we can get this right away. We know that our N is 5, P is 0.3, and S is 3, 4, and 5. So we just get it from the table and put our answer here. For 3, let's look for the table for N5, first of all. We go to the table. Is it? Okay. So this is N11. So we need to go to N5. This is why I have N5. And X, the table is using R for X. So 3, you can say 3, 4, 5 for X. So, and our P, what's our P? I think our P is 0.3, I believe. Our P is 0.3. Our N is 5. So we need the probability of X, 3, 4, 5. So for X3, okay, our P is 0.3. From here, you go to N5, which is right here. See, N5, and S start on 3. From 3, you go to under 0.3. You can see right here. Maybe I should make it bigger. Okay. You can see the 0.3. See, at 5, 3, 4, 5. So 3, go under 0.3. You can see right there. See, under 3. For 3, and N5, and P 0.3. For 3, you get the answer is 0.132. We go and write them down, 0.132, 0.132 plus 4, we got, it is just under 3. You can see right here, for 4, see 4. Under 0.3 is 0.028. 0.028. And for 5, we can see it under 75 and under 5 as 5 and under this 0.3. That's right, 0.3 right there. 0.002. See how fast it is. 0.002. Instead of calculating 1 for 3, for 2 and 4, and then adding them. So you just have the answers in, and we can get this right away. Let me write it down so I can remember it. 132, 0.132 plus 0.028 plus 0.002. So I can put them in now in a calculator. Okay, 0.123, 132, I mean to say, plus 0.028, plus 0.002, 0.162, 0.162, okay, 0.162. All right. 0.162. Any question? Question? Yeah, no question. Good. Now we can look at the mean.
Excuse me, sir. Can I see the question, please?
Take a photo of it. See the photo, right?
Yeah, can I see the previous one?
Huh?
The previous question.
That's it right here. Okay. Got it? Got the picture, right?
Yes.
We have 4 minutes left. So let me use it to introduce this. The mean, variance, and standard deviation of a binomial distribution. The mean is just n times p. Variance is n times p times q. And then standard deviation is just the square root of variance. So let's apply this to this one. For example, here, say find the mean, variance, and standard deviation. So in that case,
Professor, I have a question. When you have the exam or the quizzes, would we have that the formulas before the question or something like that?
you can write the formula. You're allowed to use formula. You can write it down. It's there on the handouts. So, and it is also in your textbook.
So we don't need to cram it for the exams.
If you want, you can memorize it, if you like, but the main thing is to understand it and how to use it. If you use it over and over, it will register. All right. So let us try the first one. Just one of them. It's not. This one is the easiest one part of this topic. It's the final part. So mean. Part A, solution. We have n. N is given and P is given. Okay. N and P are given. So let's get our Q. Q is always 1 minus P, which is 1 minus 0.75. Okay, which is, if you subtract this, you're gonna get 0.25. You can double check this. So that means the mean equals n times p. Okay, which is n is 100 times p is 0.75 equals 75. Variance equals n times p times q equals here our n is 100 times p is 0.75 times q is 0.25. So this, you can see that it's easy. So I'm going to multiply this so you get the answer. Okay, we got 100 times 0.75 times 0.25. Give me 18.75. 18.75. 18.75. So that's the variance. Standard deviation. Deviation. Okay, yes, is square root of variance. We got square root of variance. All right, square root of variance, which is the square root of that number. Square root of 18.75. I'll give us the answer. 18.75, square root of 18.75. Okay. Square root of 18.75 is 4.33. It's 4.33. So that's how you get it. It's very simple. So I do the rest of them. Is the same process. Find the Q and then multiply them out. That's all. You get the mean, variance, and standard deviation. So we have less than a minute. And